Hi everybody. Okay, today we're going to talk about probability distributions. So a probability distribution is a listing of all possible outcomes with their associated probabilities. Now there are discrete and continuous probability distributions. We're going to focus on discrete distributions for this lesson. So one thing that's got to be true is the probabilities have to add up. When you find all of these associated probabilities, they have to add up to 1. Um, so mainly, I'm going to be giving you scenarios, and you're going to construct a table, make a histogram out of these probability distributions. We're going to find the mean, which is also known as the expected value, and we're going to find the standard deviation. And all the examples that I give you, the probabilities are going to add up to 1, but this is true. They have to add up to 1. All right, so let's take a look. Let's go to our first example. So these are kind of extensions of normal probabilities. These distributions are when you look at everything that can happen instead of just one thing that can happen. So let's start with an example where I'm going to flip a coin 3 times, and I want to focus on how many times head shows up when I flip a coin 3 times. So first I'm going to write out the sample space over here so we can see what it looks like. So I could get heads all 3 times. So this is first flip, second flip, third flip. This is every possible scenario that can happen when I flip a coin 3 times. Now if I want to make a probability distribution, what I have to do is look at what are the possibilities and how likely is it. So there are 3 possibilities. I could get 3 heads. Let's start with 0. I could get 0 heads. I could get 1. I could get exactly 2. Or I could get exactly 3. So this would be all the possible scenarios. And when you do a probability distribution, we have to have numbers. We can't use like categories. So this is numeric: no heads, 1 head, 2 heads, 3 heads. Then we have to give their associated probabilities. So these are all the possibilities. The probability of getting no heads, the probability of getting 1 head, probability of getting 2, and so forth. Now, how do we figure that out? Well, a probability of an event is the number of desirable outcomes divided by the total outcomes. Right? Remember, that's our basic definition of a probability. So in this case, there are 1, 2, 3, 4, 5, 6, 7, 8 total outcomes. If I want exactly 0 heads, that is 1 possibility out of 8. So that would be 1/8, which I could write as a decimal. I will, 0.125. What's the probability of getting exactly 1 head? Well, there's this one, 1, 2, 3. 3 out of 8. So that'd be 3/8, which is 0.375. What's the probability of getting 2 heads? 1, 2, 3 out of 8, 0.375. And what's the probability of getting 3? Oh, I messed this up, right? Probability of no heads would be that 1. It's still 1/8. Probability of getting 3 heads is 1 out of 8. So the numbers are right, but I kind of said that backwards to start with. And this would be 0.125. So now look closely here. These are my possible scenarios, and these are the associated probabilities. So kind of how we lay this out when we're doing formulas is X is an outcome, and P of X is the probability of that outcome. What do I mean by that? See this X? See that X? If this is the outcome, this is the probability of that outcome. If this is the outcome, this is the probability of that particular outcome. If this is the outcome, one head, this is the probability of that outcome, probability of one head. So this is X, this is P of X. What you got to take away from that, more than memorizing, is X's are the things that can happen, and it's got to be a number, and the P of X is the probability of each one of those things. So you're going to have, like, it's not just one X and one P of X, it's a whole bunch of them. All right, so I said that we were going to make a table. So right now I've just shown you what the distribution would look like. Now I'm going to have to erase this. The nice thing about video is you can always back it up if you want to see where this came from. But I need the space, so I'm going to erase this. So one of the things I'm going to want you to do is make a table, and I'm going to right out of the gate, I'm going to make a full table, right? So far, this is what our table would look like. So here's where I list all the possible outcomes. I could get no heads, one head, two heads, three heads. And this is the probability, and I'm just going to put them in decimal. By the way, if you add those all up, those do add up to 1, right? So these add up to 1. All these probabilities, the probability of all possible things happening has to equal 1, and it does. Okay, so that's kind of the basic table. But I did say we're going to find the mean, and we're going to find the standard deviation. So I'm getting a little ahead of myself, but I'm going to make a column for mean, and I'm going to make a column for standard deviation. And we'll come fill these out in a minute, but the second thing, if you go back, that I said we would do is we're going to make a histogram of this probability distribution. So when I'm doing this, let me put these down for a second. We only need those two columns for the histogram. Now remember, a histogram is kind of like a bar graph, except it's got to all be numbers and the bars have to be touching. So what I'm going to do is I'm going to make a little grid like this, and down here I put all the possible outcomes, and here's going to be these probabilities. Now I only have to get up to 0.375. I'm just going to go up to 0.4 and count it off by 0.1s. 0.1, 0.2, 0.3, 0.4. See, that'll fit all my data. And they're nice convenient intervals there. So now I'm going to make a bar for each one of these. So the likelihood or probability of 0 is 0.125, right about here. The probability of getting 1 is 0.375, and 2 would be 0.375, and 3 is back down to 0.125. So this would be my histogram. There's my table, there's my histogram. Okay, so now we need to tackle the mean and the standard deviation. I'm going to get rid of this. Now that we have our data, we don't really need to see the sample space anymore. The mean is the sum of all the x times p of x's. So let's just do that for a minute. Now the way I would set this up, I'm going to just say, like, for when you're doing this on the test and like doing your homework, not all your professors are going to have you do this, but I think this is a nice way to arrange it to make sense. See, this is the sum of all the x times, see the x and the p of x? So the mean, our answer is actually going to be this box. This is the mean. Whatever's in that box. Now to get that, I need to find all of these individual products. So I'm going to get my calculator. 0 times anything is 0. That one was easy. 1 times 0.375. That's easy. 2 times 0.375 is 0.750. And 3 times 0.125 is 0.375. See, that is x times p of x, right? That's all the products. That's this part of it. And the mean is going to be the sum of all of those numbers. So I'm going to add those up. Plus 0.375 times 2. And I get 1.5. So that's my mean. That would be the answer if I ask you for the mean. It's not all these numbers. This is the work that gets you the mean. Okay, how about that standard deviation? The standard deviation is the square root of all the x minus the means squared times the associated probability. What does that mean? So let's play that out. Now, I'm going to show my work in red here because this gets a little busy. So to compute this first one, this is the x, and that's why I got to do this first and this second, because I have to use that mean to find my standard deviation. So I'm going to go x, 0, minus the mean, 1.5, and I have to square that difference. And then I got to multiply by that probability. Right? So it's this x minus the mean squared times the probability that goes with that x. See, those are packaged together. And by the way, don't forget to square root it. Now, that's the work. Actually, you know what? This is going to get way too busy, so I'm going to just shove that down here. For this first one, it's 0 minus 1.5 squared times 0.125. That way I can put my answers right here, and I'll put my work on the side. And I'm going to shift to black, just so I don't got to keep switching markers here. So I have negative 1.5 squared times 0.125, square root it, and I get 0.530. Okay, now I'm going to do the 1. So that's going to be the square root of 1 minus 1.5. 1 minus the mean. This is going to stay the same in all of them. Times 0.375. As a matter of fact, let's just set them all up so you can see how similar they are. This one, to get this number, I use this calculation. This one is this calculation. This one, that's my x. Mean is the same, and that's my that's my probability. And then the last one, this is my x, the mean is the same, and that's my probability. So now I have to do a bunch of button pushing. This one is going to work out to be the same. This one is going to be 0.094, and this one will also be 0.094, and now I just have to add those up. See, I have to do, the standard deviation is the sum of all those. Just like this was the sum, it's the sum. So we have to add all of those up. .154. So what did I just do? That's my table. I extended my table so that when I get to the mean and the standard deviation, I could just like go across. Like it's just a little easier to get to work that way. But that's my mean. That's my standard deviation. and that is my histogram. Okay. Well, that was our first time through. That's kind of a basic example. I'm going to do another one. It's a little more abstract, so if you want to just go back through and watch that again. The only thing I really wish I had done differently is this is the sum of all of those, right? So just keep that in mind. But I'm going to give you another example now. What we're going to do is we're going to kind of make our own game where you roll a die and you award certain prizes, right? It's going to be like a money game. So first, I have to give you the scenario. But I think what I'm going to do is I'm going to write these formulas up top. Okay, I'm doing it again. The sum of those all right, that way they're up there. So first I have to give you the words, and that's going to take up some space. I'll have to erase, but here's the scenario. You roll a die. If you get 4, 5, or 6, you pay or lose $5. If you get a 2 or 3, you win $2. And if you get a 1, you win $10. So there's 3 scenarios. And this is the game we're going to play, right? Hypothetically, we're not really going to do it, but we want to, let's say, play a game where you're playing for money. And so we make up our own rules, and here we go. Well, how would I make a probability distribution out of this? Because ultimately where we're going to go with this is we can see, like, are you more likely to lose money or win money just looking at the probabilities? And that is something that's useful to know. It can be applied in a lot of ways, not just like gambling things, but this is a nice, easy scenario where we can kind of play with the concepts. First of all, how many outcomes are there? Well, this can be confusing because it's like, well, I could get a 1, 2, 3, 4, 5, or 6. So you might think there's 6 possible things. However, there are 3 possible outcomes as far as winning the prizes go. I could lose $5, I could win $2, or I could win $10. So those are 3 possible outcomes. And then I got to look at the probabilities. So I have to erase this. So remember what the rules are. Okay, so we're going to make a table. And we're going to expand it because eventually we've got to find these values. Okay? So I would just do this every time you're doing one of the problems. It helps us to get structure and form and think through the problem. What are my possible outcomes? I could lose $5, I could win $2, or I could win $10. Those are my possible outcomes. Well, what are my probabilities? Well, how could I lose $5? Roll a 4, 5, or 6. So that would be 3 things that lose $5, 3 desirable outcomes out of 6 possible outcomes. So that is a probability of 0.5, right? If that's weird, just think about it. It's rolling a die. 4, 5, or 6. That's half the numbers. So that's 0.5. How could I win $2? Well, I could roll a 2 or a 3. That's 2 desirable outcomes out of a total of 6. So that's 1/3 or 0.3 repeating. Finally, I get $10 if I roll a 1. That is 1 desirable outcome out of 6 total. which would be 0.167. And let's just make them all 3 decimals just for uniformity. So there are my outcomes with their associated probabilities, and that creates a probability distribution. Well, what are we going to do with that? We are going to make a histogram. That's what we'll do next. So let's see. I could have minus $5, plus $2, or plus $10. I got to get up to 50%. So I'll go 10, 20, 30, 40, 50%. Okay, so to lose $5 would be this probability. To win $2 would be this probability. And to win $10 would be this probability. Right? It gives you a nice visualization of this is what could happen, and it's just the higher the bar is, the more likely it is that that's going to happen to you. So there's my probability distribution, these first 2 columns. There is my histogram. Now I could ask you, what is the mean of this probability distribution? And that is the same as saying the expected value. And it's called the expected value because one way to interpret the mean is, if you did this like a gazillion times, like how would this average out? How much money would I win or lose if I did this, like, let's say I did it 1,000 times? On average, would I be paying money or would I be winning money? Well, let's see. How do we find a mean or expected value? I have to multiply the outcome by its associated probability, and then when I get them all, I got to add them all up, and this will be my mean. So 5 times 0.5, that'd be negative 0.25, right? And then I'd have 2 times 0.3, that's 0.667, right? If you write 0.666, that's fine. Just remember, that came from a third, so it's really 2/3. If you put 0.66, that's fine. This is 0.167 times 10, so that would be 1.67. If you were thinking this is wrong because it's minus 2.5, I agree with you, minus 2.5. So let's see what we get. Minus 2.5, this calculator. Minus 2.5 plus 0.667 plus 1.67 is minus 0.163. Now, before we even go any further, what does that mean? That is called the expected value because what that tells me, the way I would interpret this is, on average, I would expect to pay 16 cents. Right? So this is a losing game. And by the way, if you go to a casino, all games are losing games. It's set up for the house to win and for you to lose if you play often enough. So this is saying if I play it over and over and over and over and over again, on average, I can expect to lose 16 cents every time I play. Okay, so that's the interpretation, and that is why people care about finding the mean, because it has a real life applicable interpretation that we can use. All right, so let's look at our standard deviation now. How do you get it? Well, here's the formula. So we have to take x, subtract the mean, square that, and then times it by the probability, and then then square root it, and we're gonna write that down, and then we do it again, and then we do it again, and then this is the sum, so we will add those things up, and this will be my standard deviation. All right, so I'm gonna do my work to the side here, but I'm gonna erase it. So let's see, row 1, square root of minus 5 minus a negative 0.163 squared times the probability of that happening is 0.5. I'll punch that in my calculator in a minute. Row 2, the square root of 2 minus a negative 0.163 squared times the probability of that happening. Row 3, that x, that outcome, minus the mean, so minus a negative, squared, times the probability of that happening. So I'm going to do all the button pushing here. Let's see, minus 0.5, square it, times 0.5. That gives me 0.057. 2.163 squared times a third is 1.558, and 10.163 squared times 0.16. Oh shoot! I gotta back this up. Minus 5 plus 0.163 squared times 0.5 and then I got to square root that. 3.420. I better do that again. Sorry about you watch me punch buttons here. Okay. Second one. 2.163 squared times a third. Then I got to square root it. 1.248. Third one. 10.163 squared times 0.167. Then I got to square root it. 4.153. And now I'm going to add all those up. And I get 8.821 for my standard deviation. All right, so, be careful with the calculations. I just messed them up myself by forgetting to square root them at the end. But there's my mean and standard deviation. So what's this going to look like on a test? On the test, I'm going to give you like either a scenario or list out probabilities. And you need to make a table like this. You have to make a histogram like I just erased. And then you have to state the mean. This is all the work, but I want you to separately state so I can see that you know that just that number is the mean. And you need to state the standard deviation, right? The end result, I want you to pull it out of that table. For a third example, let's try more of a common real-life scenario. Suppose you want to raise money for charity or something, and so you're going to have a raffle. And we want to make sure that we actually make more money than we pay out. When you do a raffle, people buy tickets, and like so many get prizes, like get money, they win money. And you want to make sure you're taking more money in than you're spending out because you want to give it to the charity or whatever. So we have to make sure this works out. And to do that, we're going to do a probability distribution. So the first thing you got to decide is how many tickets are you going to sell? Let's say like it's a really big, like maybe it's on the campus and most people are going to chip in. Let's say you want to sell, we're going to sell 1,000 tickets. Okay, so we think about prizes, and let's say we think in clumps of 100. So we'll make it one ticket wins $100, 2 tickets win $50, 5 tickets win $20, 10 tickets win $10, and 100 tickets will win $1. Right? So that's 100, 100, 100, 100. That's $1, 2, 3, 4, $500 that we're paying out. We're selling 1,000 tickets, and we're going to be paying out $500. So I guess I could do, without doing any statistics, I could say, let's charge $1 a piece and we'll make $500. But let's say I want to get a little more precise. I want to look a little bit more closely at what's happening here. So how do I make a probability distribution out of this? Well, the first thing we do is we make a table. So we have our x's and our p of x's. And in a minute, we'll expand this to include, we're going to find our mean, which is our expected value. But let's just focus on this. This is our probability distribution right here. What are the possible outcomes? You're looking at them. Oh, right here. These are my possible outcomes. You can list them in whatever order you want. I'm going to reverse the order. I could win $1. I could win $10. I could win $20. I could win 50, or I could win 100, or actually, sorry to do this to you, I could win nothing, right? I didn't list it there, but if I buy a ticket and it doesn't get chosen, I win nothing. So I could win nothing, 1, 10, 20, 50, or $100. Well, what are the associated probabilities? Well, one ticket wins $100 out of 1,000. Well, that would be my probability. 1 out of 1,000. And punch, 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 that gives me 0.001. What's the probability of winning $50? 2 possibilities out of 1,000. So 2 out of 1,000, which should be 0.002. What's my chances of winning $20? 5 out of 1,000. So that'd be 0.005. How likely is it I'll win $10? That would be 10 out of 1,000, or 1 out of 100, which is 0.01. We'll throw an extra 0 in there for kicks. What's the likelihood that I'll win $1? Well, let's see. To win $1, there's 100 chances out of 1,000 tickets. That would be 0.100. And what would be my probability of not winning anything? Well, I got to figure out how many this is. So let's see. There's 100, 110, 115, 117. There's 119 winning tickets. So that means there's 881 losing tickets, meaning they don't win anything, right? 9, yeah. So that would be 881 tickets don't win anything out of 1,000. And if you add those all up, those should be 1. That is my probability distribution. This was just work. Let's get rid of that. There's my distribution. I'm going to make my histogram last because I need the space, so I'll clear this off when I'm ready to do my histogram. But right now, I can tell you, I'm definitely going to ask you for the mean here. So let's create a column for the mean and the standard deviation. And I am going to need some space. So let's see. For the mean, what do I got to do? I simply multiplied the outcome by its probability. That would be 0. This would be 0.1. This would be 0.1. I believe this is 0.1. We'll just make sure. And this is 0.1. And this is 0.1. Well, that's convenient. They're all 0.1. And so my mean is going to be 1, 2, 3, 4, 5, 0.50. Okay, so my mean, that means the average ticket is going to pay out 50 cents. So if I buy a ticket, like if I bought a whole bunch of tickets, I could expect that the average one is going to pay me 50 cents. Okay. So now let's find the standard deviation. To do the standard deviation, I need a little bit of space here. Here's the formula. So this one is going to be, here's my mean, the square root of 0 minus 0.5 squared times 0.881. 0.5 squared times 0.881 to the 0.5. So that would be 0.469. This one is going to be 1 minus the mean times its probability. And square root it. 0.158. Next is 10 minus 0.5, the mean, times its probability, which is 0.1. Oh. Hold on. Times it's 10 minus the mean times its probability, which is 0.01. Gotta slow it down here. 9.5 squared times 0.01 square root. 0.950. Oh my goodness. I gotta recompute. 158. Sorry about that. All right, next one. X minus the mean squared times its probability. So 19.5 squared times 0.005 square root 1.379. I'm on the 50. 50 minus a half times 0.002. That's 49.5 squared times 0.002 to the 0.5. 2.214. And the last one is 100 minus 0.5 times its probability. 99.5 squared times 0.001 square root it. 3.146. So my standard deviation is the sum of all these numbers. I'm getting 8.316. So I've done everything but my histogram. We'll knock that out. I got to get rid of this to make room. Remember, for the histogram, we're only doing these two columns. So these are my outcomes. And my probabilities, well, they go all the way up to 1. This, I better make this pretty tall. If this is 1, 0.5, 4, 6, 7, 8, 9. Okay, so this is most likely you are going to win nothing. The probability of getting a 1 is 0.1. 20 is 0.05. Oop. Skip 10. 10 is these get really hard to see. We really don't have a lot of choice. I'll tell you on the test, I'm not going to have you do a histogram for this because this is so skewed, the 0, 1. But these just get really, really small, hard to see. Right? This would be at the 0.1, 0.1, 0.01, 0.005, 002, and 001. So the other histograms look much nicer. I will have you do those on the test. This, I will be giving you a raffle ticket problem. I'll just tell you that up front. And you won't have to do this, but I will want to see this table. I'm also going to be asking you a final question. How much must we charge per ticket to make a profit? That'll be a question. And the answer I'm looking for is basically this. Anything over 50 cents. How do I know that? If this is my expected value, I've got to charge more than the expected value to make a profit. If I charge less than that, I'm going to end up losing money, right? So it depends how much profit you want to make, right? So some organizations might charge $5 per ticket. They make a lot of money. Another organization might just charge $1 per ticket and make less. But this would be called the break-even value. This is how much you got to charge. All right, so practice these. In the notes that I give you in Brightspace, there will be practice problems. What I've done here is going to be very close to what I'm testing you over, so be sure to focus on these skills. All right, take care, and we'll pick up soon.